Hello friends, today we are learning Arduino and Python communication. So we'll try to blink a Arduino LED with the Python code or Python inputs with the help of serial communication. In my right side, this is our Arduino IDE which we have learned in Arduino's introduction session. And in left side it's a Visual Studio where we have written the Python code. So this is our Python code for serial communication with Arduino, and this is our Arduino code for to receive the information from Python and take an action accordingly. So let's start with Arduino side. So as I have already explained in earlier video that Arduino has inbuilt LED that is on port number 13. We are talking about Arduino Uno which we use for our project. So pin number 13 has inbuilt LED which we use to blink LED here from the Python inputs. Now we have taken a variable incoming byte which we will receive from Python side, and based on that we'll take the action. In setup, in Arduino I have already explained that two sections were there, setup and loop. Setup used to execute one time only and loop execute multiple times. So in setup we have make our LED pin, so that is pin number 13, to a output pin to send the information outside of the pin, that is to LED. And we have declared the serial communication begins with baud rate of 9600. So that is our baud rate. Baud rate is bits per second. You can consider it the speed of communication between two devices while they are doing a serial communication. So it is mandatory to define here, and ideally we use 9600. There are multiple options for baud rate that you can Google it or you can search it, or I'll explain it later. So default is 9600 which we use for serial communication. In loop section, we have checked if serial is available. If anything in serial port is available, then it will wait for that. Once we'll receive something on serial port, it will read that value from serial port and put that value into variable incoming byte. With the incoming byte variable, we are checking if we received H, that is capital H, so we have to send capital H only. So if we have received H, what we'll do, we'll write digital write on pin number 13 the high. So pin number 13 will send high, and if we receive low, then on pin number 13 we'll send low. So the LED will be off in this case, and in this case LED will be on. So when we receive H on serial communication, the LED will becomes on. If we receive the H, LED will becomes low or off. Another side in Python code is also simple and similar to Arduino one. We have imported serial library here and time library just for delay purpose. In serial library, we also have that serial ports available which we use to check on which port our Arduino is connected. So first what we did, we need to know on which port our Arduino is connected. So what we can do, we can comment this whole code, and we can comment this whole code and we can run the application. So you can see we have received the port entry here which we printed. So this one is our port ID which we use to communicate with Arduino. I'm using Linux, so this is port ID on Linux device. If you are using Windows, it might be COM0, COM1 something. Once we are confirmed with the port, we can comment this code. So it will list out, we are listing all the ports here. So right now there is only one device connected with me. You can see only one device is there, Arduino, and there is no other pen drive or any other device connected on USB port or serial communication port. That's why it's listed only one. If there is multiple, it will list multiple devices. You need to choose wisely. For our Arduino communication, you can also find out this same port which we get here from Python code. This one you will find here where our Arduino is connected. So that is, you can see it is same mentioned here in Arduino ID below with the Arduino Uno name. So you can directly use the name from here also. So once we'll get our COM port, on which COM port our Arduino is connected, we can comment this section. We need only the below code to communicate with the Arduino. Now what we are doing here, the same thing which we did in Arduino, we need to begin the serial communication, we need to set the baud rate. So here we are setting the baud rate to 9600. Arduino itself, Arduino Uno kit itself has only one serial communication port, so there is no need to give the port. But here in our system or laptop we have multiple communication ports, so we need to give the ports. So first we'll give the same port on which our Arduino is connected. In that port we are setting same baud rate which we set Arduino to communicate on that. So once we set the baud rate, both the devices are ready to communicate to each other on this port with this speed or this baud rate. After setting baud rate, we have just added some delay or sleep to Arduino and Python to communicate. It's a 2-second delay only. We can reduce it to 0.5 also. That is half second. Then we printed press H to turn on LED and press L to turn off LED. Now after that we are having a loop for 10, and in that loop we are taking input, and that input key we are just encoding that to byte, because by default the input variable values are Unicode in Python. So what we need that in bytes to send on the serial communication. Once we encode that to byte, we can use serial. That ser is this variable we use for serial initialization dot write. So it will write that information to Arduino, whatever information we type here. And what we will type H or L, and then after sending information we are giving 1 second delay. Then we'll continue for the next input. As it is loop, it will ask 10 times the different value. Now let's run the code. We need to load the Arduino program to the Arduino device first. We already have learned this in earlier session. We can compile and then click on upload. That upload will upload you can see done uploading. So it is uploaded to Arduino device. This code has been moved to Arduino device, Arduino's inbuilt IC or inbuilt chip. Now we need to run the Python program, and the Arduino will receive the information based on that, and it will start blinking the LED. Now you can see our print statement which we printed, print H to turn on LED and print L to turn off LED is printed here. Now let's see how it will work. In Arduino we have inbuilt LED on here, and also have the receive and transmit section or LEDs. So whenever we receive or transmit information from Arduino, these LEDs will blink, and whenever we pass the information H or L, this LED is our target LED which will blink. Now I am giving H, so you can see LED is turned on. When I give L, LED is turned on. If it is already low and I am giving L, it will not turn on, but you can see the RX LED of Arduino is blinked. I am giving again L, so receive LED is blinking, but that LED didn't turn on when we give L and turn on when we give H. Now I am giving L to turn off. You can see RX LED also blinks one time. whenever it receives any byte. So I am giving H again. So our LED, targeted LED turn on. Also the RX LED will blink that indicates that we received the signal from the device. So I am again turning it on. It is already on and I am passing H, so there nothing will happen, and I am giving L at the end. So by this you have seen we have turned on and off Arduino LED with the help of Python. You can make many such applications or such programs to communicate or send a signal through Python to Arduino or to Arduino to Python. In later videos, we'll learn how to receive signals from sensors with the help of Arduino, and that sensors information will pass through Arduino to Python, and Python will receive that sensor information and take the respective actions. So right now in this video we have learned receive in Arduino and sending from Python. In next we'll do vice versa. We'll send signal from Arduino based on sensor or something and we'll receive that on Python. Thank you for watching.